Hello students, this is the last lesson of chapter 6, just adding a different perspective to what we've been doing up to now. In terms of linear relations in chapter 6, we have been looking only at increasing linear relations. So what I mean by that is we had a number of tiles and they increase from one position to the next. We have also looked at constant values, and those constant values were either 0 or some kind of a positive number of tiles or something like that. But that is not the only option. So right now we're going to cover the other aspects of linear patterns, and that includes negative numbers. So what I mean by that is we can have negative numbers in both rate of change, m, and in both constant or y-intercept, b. So I'll start with b because that's what kind of talks about in the lesson. If you have b that is a negative value, remember that value only represents where our line, a straight line, crosses the y-axis. So all it means is, if I have like -2, that means that my line is going to cross the y-axis at -2, and that's it. Nothing else. So how does that look like in an equation? Well, might look something like this. Y equals 3x minus 2. There we go. So instead of plus 2, we have minus 2, which represents our p-value. At the same time, you can have a negative rate of change, m, and what that means is if I have m equals negative something, instead of the line increasing, instead of it going up, it goes down. So it is something like this. Instead of going up like this, it's going down like that. How does that translate into what we've been talking about, rise and run? Well, um, I'll say it right away. You should remember this all the time. Run is not negative, ever. So run always goes to the right. So always run that way, run that way. What changes is whether you're going up or down. So when you have a rise, it's going up. So in this case, you have a positive rise goes up. If you have a negative rise, well, negative rise is the opposite of rising. It's kind of going downwards. So if you have, in this case, a rise of -6, that means you go 6 units down. And that's pretty much it. So the difference is whenever you have a negative rate of change, your line is going to be going down and to the right. So if you remember talking about trends, that's what we were mentioning. And that's pretty much it. Finding equations is going to be the same way. So let's do it. It says determine the equation of the linear pattern rule and of the linear pattern rule for this graph and write a story problem matching the graph for your rule. So there is a solution on the next page, but I'm just going to go through it with you on this page. I know that my equation is still going to be y equals mx plus b. That hasn't changed. I know that b value is the value where my line crosses the y-axis. So in this case, it crosses here at 20. So it's going to be at least y equals mx plus 20. If it was a negative value, then it would just be minus. So now I'm going to find my rate of change. If you remember, my rate of change is rise over run. For this, I need to pick 2 points. So I will pick this one, and I will pick this one at the end. There we go. They were nice points. So my run is horizontal. So it starts at 0, and it's going to 5. So I know my run is 5. My rise is actually a negative rise. Imagine, think of it again like floors of a building. You know, you're on the 20th floor, and now you go down to 0th floor. So you're going all the way down here, which means that you went down 20 floors, so -20 floors. So that means my rise is actually -20, which means that if I divide this, -20 divided by 5 is -4. So that is my rate of change. What does that actually mean? Well, it means that for every 1x value, my y value goes down by 4. So 4 over 1 over. 4 down, 1 over, and so on and so on. What does that mean in terms of our equation? Well, we put it all together. It's going to be y equals -4 x plus 20. There we go. And that's our equation. I'm just going to jump to the next page. To show you pretty much they have the same thing. If you want to, you can go kind of through their solution. And here's what the story they had. So they had, I have $20 in my bank account. That's what I'm starting. That's my starting value. And each week I withdraw $4 to buy my favorite hockey magazine. So that's the minus 4. How many weeks will it take for my account to be empty? So that is some kind of a story that you could write. All right, moving on to our practice question. For each equation, complete the table of values, then draw the graph. We are given an equation, y equals 3x plus 4. You should know right away that this is an increasing linear relation because the rate of change is positive, so it's going to be going up. And it's going to be crossing the y-axis at 4. So that means here, there's a point. So when x is 0, y is 4. So I can enter that here right away. And now I can do it, I can create a table of values a few other ways. I can use substitution, so I can go and substitute negative 3 in the equation. Y equals negative, actually 3 times negative 3 plus 4. 3 times negative 3 is negative 9, plus 4 is negative 5. So it would be negative 5. I also know that it's increasing by 3, so I can just derive the other ones by just adding 3 every time, plus 3. So negative 5 plus 3 is negative 2. Negative 2 plus 3 is 1. 1 plus 3 is, oh, 4. It works. And then plus 3, and then plus 3. So this is going to be 7 and 10. There we go. Um, Usually what I like to do is what I kind of started with. So let me just erase this, and I'm just going to show you the other way. There we go. So I started with 0, 4. I know that it's increasing by 3, plus 3, plus 3. So I know it's going to be 7 and 10 in this direction. In the other direction, I just have to subtract 3 because I'm going downwards instead of increasing. I'm going decreasing. So it's going to be 4 minus 3, which is 1, minus 3 minus 2, and then minus 3 is negative 5. Again, I derive the same table of values. It says draw a graph. So I can take the points, draw them, do all that stuff, but I'm going to show you another way. I'm going to show you how we graphed. Actually, I already showed you that, how we graph it from the equation. So I know that at 0, I cross the y-axis at 4, and I know that for every horizontal unit, I increase up by 3. So that means 1 over, and then 3 would be the next point, which is here, 7. And then 1 over, and again to 10. So there we go. I really only need 2 points to generate a graph. So I don't know, something like this, let's say. If you have a ruler, which you should just use it. And there we go. That is my visual representation of this equation. So this is y equals 3x minus 4. That's how we label it. Sorry, 3x plus 4. So we have 3 representations here. We have an equation. We have, sorry, that's a bad check mark. We have table of values, and we have a graph. All we are missing is a story. All right, moving on to the next practice questions. It's identical. So I'm going to do it very quickly. I know that my b value constant is at 6. So when x is 0, my y is 6. I know that my rate of change is 4. So that means it's increasing by 4 every time. So this is going to be 10, 14. And then in the other direction, it's going to be minus 4. So 6 minus 4 is 2, negative 2, negative 6. And again, I can generate the graph, but I'm going to do it by using y-intercept and rate of change. So y-intercept was 6. Here we go. And rate of change is 4 up for every 1 over. So 4 is 10, and here. And that's all I need. I have my 2 points. Actually, it's pretty good. There we go. Maybe a little lower. That's pretty good. There we go. And that is y equals 4x plus 6. There we go. Moving on to the next question. Choose one of the graphs from question 1. Write a story problem for the graph. Okay, so it doesn't matter which one we want. So here's a story problem. I'm going to choose this one because it's right on the page, and I'm going to use a similar example that they use, and I'm going to say I have what is it, $6 in my bank account, and every week, every day. Actually, you know what? Every day, I put in $4 in order to save for something new, for something to buy. I don't know. Something to buy. How long will it take me? How long will it take me? Oops. Take me to save, I don't know, $100. There we go. That would be a story question, just describing this. All right. Moving on to next question, it says determine the following for each set of data. So it says initial temperature, first differences, rate of change, and equation. Okay, so we're going to find all of these things. So we have A and B. It seems like it's showing temperature over a certain amount of time. They are starting at 0. And as you can see, one is increasing, one is decreasing. So initial temperature for this first one, it is 2. So at 0th hour, it is 2 degrees Celsius. So I'm going to start working towards my equation right away. I know that my equation is going to be mx plus b. And because my initial temperature, if you remember initial value, that's my b value. So it's going to be mx plus 2. Then it says first differences and rate of change. So I'm going to find a rate of change by using actually first differences. If you remember, we're just going to subtract 5 minus 2, 8 minus 5, 11 minus 8, and 14 minus 11. And luckily, the answer is 3, which means we're dealing with linear relation. So that's first differences. Because my time is increasing by 1, this also represents my rate of change. So my final equation will be y equals 3x plus 2. And that's it. Moving on to B. B is a decreasing relationship. Initial value is 10. For 0th hour, it is 10, so I know that it's going to be y equals mx plus 10. Um, First differences, we are subtracting. In this case, it's 8 minus 10, 6 minus 8, 4 minus 6, 2 minus 4. And if we calculate this, no, the answer is not 2. It is negative 2. Negative 2, because for every hour, there is a decrease in temperature. It's getting colder. So in this case, that is our rate of change. Our m equals negative 2. So my y value, my equation is negative 2x plus 10. There we go. So the first one was increasing. It's going kind of like this. Temperature is getting hotter, I guess you can look at it. And this one is decreasing. Temperature is getting lower. All right, moving to the next question. It says, for each set of temperature data in question 3, previous one, predict where the graph crosses the y-axis. Predict where the graph slants, excuse me. All right, I'm back. Predict whether the graph slants upward and downward. Verify your prediction by graphing. All right, here's our two equations, 3x plus 2, negative 2x plus 10. So first one, predict whether where the graph is crossing the y-axis. So remember, that's our b value, which is 2. So y-intercept is 2. Slants, is it going upward or downward? I'm going to say up because we know that it's positive rate of change, so it's increasing. And then confirmed by graphing. So I know that it's starting at 2 on y-axis. And for every 1 unit horizontally, it goes 3 up. So it goes from 2 to 5. There we go. And I'm going to draw a line. And there we go. That's my line. All right, let's do the same thing with the other one. I'm going to use blue. All right, so y-intercept in this case is 10. There we go. Slant is going to go down. And we're going to confirm that. Okay, we're going to start at 10. And for every unit horizontally that goes over, it goes 2 down. So it's going to go down to 8. There we go. And we get our line, something like this. I will correct that a little at the top there. There we go, something like that. Perfect. And that's our graphs. Pretty straightforward. Moving on to the next one. It says, for the pattern for the pattern shown, determine the rate of change in the number of tiles. Okay, so first position, second position, third position. In the first position, we have 4 times 4, which is 16 tiles. I'm going to write it on top. Second position, we have 3 times 4, which means we lost 4. So we're going to have 12, and then we're going to have 8. So we have a decreasing relationship by -4. What is the rate of change? -4. We get 4 tiles less. The constant, remember, is the 0th term. So 0th position here. So if we're subtracting in this direction, we're going to be adding 4 plus 4, which means that our constant is going to be 20 tiles at the beginning. And the equation for this pattern rule, y equals negative 4x plus 20. There we go. I should show you something else. This equation can be rewritten in a different way, and you might see that on different types of questions. So in this case, I can write it like this. 20 minus 4x. It means the same thing. It's just instead of y equals mx plus b, it is b plus mx, or minus. That, that's how it changes. So that's it, just to kind of expose you to that. Next one says, determine the equation of the linear pattern rule for this graph. Write a story. All right, so let's do the equation. I'm going to write all of it here. Y equals mx plus b. I know that my b value is my y-intercept, where my graph crosses the y-axis. So in this case, it's 4. So I know that b is, it's not 4. Sorry, it's 30. There we go, it's 30. And now I have to do my rise and run for my rate of change. Rise over run. I do know that my rate of change is going to be negative because my line is going downwards. So 2 points that I can pick. Let's see. I'm going to pick 2. I'm not going to pick first and last. I'm going to pick this one here. There we go, in the first one up there. So my rise is actually my negative rise, which means I'm going from the 30th floor of the building to 20th, which is negative 10 floors. And my run is from 0 to 2, which means negative 5. So that's my rate of change. And here's my equation. Negative 5x plus 30, or 30 minus 5x. The reason why I write it this way now is because it might help with the story. I'm going to again use the story with the bank account. Or, yeah, actually, I'm going to use similar stories. So, um, again, I have $30 in my account. Actually, how about I don't write it? You can kind of pause and listen to it. I have $30 in my bank account at the beginning of the week, and every day I spend $5 on buying my lunch or something like that, or buying a drink or coffee or whatever people drink. So that can be an example. There we go. That's it. Moving on to the, okay, so that's it. There's some EQO practice questions which you can try. And if you have any questions, please email me.